All of you are doing it, but copy that down, give you a little bit more time.
You want to do the graphs? You want to do the graphs?
Yeah. Do the graphs? Yes. Yes, two. Imaginary, I am a she and Mary. I think you got the rest. Gonna be a big thing. This is fun already, I can tell. I still see some people copying, that's fine. Take your time. Yeah, that's such a good smile. Is this in your way?
No.
Okay, good. There's nothing I could have done about it, so I'm glad the answer was no.
Okay, okay.
All right. Moving on. All of this, I guarantee you, will be explained as we actually start solving some of these problems. But one thing I do want to point out before we go. So this graph right here, this is an example of a graph that does not have any real zeros. The way that you can tell by looking at a graph is that it never crosses the x-axis. It does have solutions, however, they are imaginary. Yes, we will be dealing with imaginary numbers again in the next day's lesson or so. Sydney, will you do me a favor?
Yeah.
That top shelf,
Yes.
very, very far left, are today's notes. Will you intend to copy to Ellie, please? Thank you.
Wait, so it said that it has no zeros, so that it has no zeros.
It has no real zeros. It has imaginary
Okay, so
numbers,
it said that it-
imaginary solutions, no real roots. Yeah. If you would, please focus here, focus here. Focus here, focus here. Here's an example of a double root. And then here's something that has two real solutions. This one has, well, one, but it's a double root. Oh, that will be explained later too. Two real solutions. This graph is crossing the x-axis twice. Now, before we go on, I handed you a separate sheet of paper because we are going to need to work on something before we start doing our Delta Math assignment today, because I have a feeling that some of you may have forgotten how to factor, which is okay. You know, if we don't practice something over and over and over again, our mind tends to forget about it. But you will be doing some factoring today on your Delta Math, and there's probably going to be some stuff that you don't remember how to do. So let's get to it. X squared minus 15x plus 56. Here's how you're supposed to factor a quadratic. Multiply the number in front of x squared, in this case 1, times the number without an x, in this case 56. 1 times 56 is 56. Now we need the factors of 56 that add to get 15. That would be 7 and 8. This symbol right here, the very last one, anytime it is positive, that means these two numbers are going to have the exact same symbol. That tells you what they're both going to be. So these are both going to be negative. And if you do the math, it should make sense. -7 times -8 is positive 56. -7 plus -8 is -15. It works. Now, this trick, I'm about to do a shortcut, only works if your leading coefficient is 1. Now that we know what our factors are, we can go ahead and plug these right into parentheses. X minus 7 X minus 8, done. Don't worry about solving that one to completion. But I just wanted to give you a level of awareness of how you would factor a basic trinomial such as that. Okay, now example B. We're going to start off the same. Multiply the number in front times the number in back. So 5 times -9 is -45. We now need the factors of -45 that subtract to get 4. That is 9 and 5. Now, anytime this last symbol is minus, it means these are going to be opposite symbols. One's going to be positive, one's going to be negative. When that is the case, look here. Whatever that is, it will always go to the biggest number. So positive, negative. And just check yourself to make sure you did it right. 9 times -5 is -45. 9 plus -5 is 4, positive 4. So we have the right factors. Now this right here, we cannot plug directly into parentheses. We have to create a factor by grouping problem. So start with your very first term, 5x squared. And now we're going to substitute our factors and give them an x. So plus 9x minus 5x, and then end with the last term. If you did it right, your problem really didn't change very much. 5x squared is still 5x squared. 9x minus 5x is 4x, and minus 9 minus 9. Okay, now what we're going to do is we're going to create a factor by grouping problem. So we're going to group those two terms together and figure out what can we factor out. It looks like here we could factor out an x. That would leave us with 5x plus 9. Now, look at my two groups here. Whatever symbol separates the two groups, you have to make sure and include that. So we have to factor out a negative. Now, the only thing that goes into 5x and 9 is 1. So we factored out a -1. And if we divided both of these terms by -1, we would be left with 5x plus 9. We have two matching sets of parentheses, therefore this can be factored, and we did it correctly. These outside terms, use that in one set of parentheses, and then keep one of the matching sets of parentheses. And now we have factored. Yes.
So I don't know if this works everything, that's why I'm asking. So I would switch the positive 9x and then the negative 5x. Seems like easier
Yeah.
to do it.
You can do that. Yes, absolutely. Absolutely. You can, you flip these two?
Yeah.
Yeah, it doesn't matter. You can do that. As long as you do your math right, we're going to get the exact same thing. Beautiful. Example C. We're not going to work this one through. It's actually, this one looks not as bad as I thought it was going to be. Okay, example C. Here's what you're really supposed to do before you begin working on a quadratic and before you factor it. See if there's something you can factor out first. The reason why I didn't do that with the first two is because there wasn't anything we can factor out first, but here there is. 1, if your leading coefficient is negative, you have to factor that out every single time. Looking at each of these numbers, they're each divisible by 4. So we're going to go ahead and factor out a -4. And that would leave us with x squared plus 8x plus 7. Now we're only factoring what we have in parentheses here. The number that we need to factor is 1 times 7. The factors of 7 that add to get 8 are 1 and 7. Same signs, both positive. And since our leading coefficient in the parentheses is 1, we can go ahead and plug these right into parentheses. So x plus 1, x plus 7. Am I right? What am I forgetting? Thank you for playing along. Yes, you're right. Don't forget, if you factored out something to begin with, you have to include that in your final answer. So this is correct, right? If we're gonna solve, yes, I'm not that concerned with you solving this one right now because these are pretty easy, but we're about to get to one in just a second where you are gonna have to solve. Question? Not whenever we are factoring, no. Okay. And then lastly, example D. Okay, let's start this one off like we did all the other ones. Multiply the number in front times the number in back. 2 times -1 is -2. We need the factors of 2 that subtract to get 3. Is this factorable? It looks like it is, because 2 plus 1 is 3, right? 2 plus 1 is 3. But this last symbol tells you what your factors have to do. They must subtract to get 3. Well, 2 minus 1 is 1. So this is not factorable. How do we solve it? Oh, we do. X equals plus or minus. Oh, mix it up. X equals B, opposite B. I'm trying to think of this song and I can't remember the song. X equals opposite B plus or minus square root. Yeah, you ever heard this song? Have you heard this song? No? Okay. B squared minus 4A. I'm gonna have to write it down, then I can sing it. Okay, there we go. All right, here's the song. Opposite B plus or minus square root of B squared minus 4AC all over 2A. No, it helps. Just sing it over and over again. I currently have me singing it on my Spotify. Go follow me and just play it in your car. You'll get it. Okay.
Just listen to it.
I learned that song like 3 or 4 years ago. I didn't. I was like, yeah.
So we're gonna memorize.
You're gonna have to know the quadratic equation, yes. So if it tells you to, okay, let's say it tells you to factor. If it tells you to factor and you can't, then your answer is not factorable. But if it tells you to solve and you can't factor, you have to use the quadratic equation. So here's what we're gonna do. I'm gonna label my terms A, B, and C. And you just can't label any of them A, B, and C. You have to be strategic. The X squared is your A, the X is your B, and the number without an X is your C. And I'm only talking about numbers here. So if I start plugging this into the quadratic equation, negative B plus or minus square roots of B squared minus 4 times A times C, and this is what students usually get wrong. All of it over 2 times A. Now, let me make sure I did all that correctly. Now, opposite B plus or minus square root of B squared minus 4 times A times C all over 2 times A. Great. Okay. What we're going to want to do is simplify what we have in the parentheses first. Not parentheses, I'm sorry, the square root. 3 squared is 9. Now, this is something else that usually trips students up. We are either subtracting all of this from 9, or we're going to add all of this from 9. Okay? I have a negative times a positive times a negative. So I'm multiplying 2 negatives. What does that equate to? A positive. So 9 plus 4 times 2 is 8. 8 times 1 is 8. All over 2 times 2, which is 4. Okay, simplifying a little bit more, we have negative 3 plus or minus the square root of 17 all over 4. Can that be reduced anymore? No. That's your final answer. You will have something like that on your Delta Math later today. If you have any issues, let me know. Now, let's get to our notes for today. It's not going to take very long. Go ahead and flip over to the back portion. Yeah, you know what? It can be in front of the three out here, or it can be out here in front. Either way, doesn't matter. Negative plus or minus. Okay, here is vertex form. There we go. Vertex form, graph the following, and then find all of its unique characteristics. So the reason why that this is called vertex form is because it's very easy to identify your vertex. Our vertex is, I'm going to do that first. Our vertex is 2, -4. 2, -4. Let's get back focused, please. Okay. We good? Better? Okay. 2, -4. You see how I got 2? Whatever's in parentheses, keep the number, flip the sign. And then the number out to the right of the parentheses, keep that. So 2, -4. That's our vertex. This graph is going to open up. The way that you can tell is look in front of the parentheses. I don't see any negative in front of the parentheses. Therefore, this is a positive graph. It's going to open up. X-intercepts. Well, we're going to find that as we start graphing. So let's first start by plotting our vertex. 2, -4. We go right 2 and down 1, 2, 3, 4. And that's where our graph begins. Now, you could create a table, a parent table, and then a transformation table and graph from there. But quadratics are a little bit easier if you know your perfect squares. So what is 1 squared? 1. So from the vertex, I'm going to go right 1 and up 1. Okay, I went right 1 and then squared it. So I go up 1.
Yeah, we're keeping one.
It's just the, you know what? I don't have like a really good answer for that other than that's just the pattern for whenever you're graphing a quadratic like this without using a transformation table. You'll always use 1 if you're doing it this way. If you're doing it this way, if you're using a transformation table, then it's different. So if you're doing it the way I'm doing it here, just always use 1. Okay. Yeah. All right. Next, and because also they're 1, it'll fit on the graph, and 2, they're very easy to solve for. That's another reason. Okay. Next, from the vertex, I want to go right 2. What is 2 squared? So go up 4. 1, 2, 3, 4. Now I'm going to go back to the vertex. I'm going to go right 3. What is 3 squared? 9. So go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now remember, opposite points of a parabola, they are mirrored. So that if I go left 1, I would still go up 1. If I go left 2, I would still go up 4. If I go left 3, I would still go up 9.
Wait, are we squaring everything to quadratic?
Yes, that is exactly why we're squaring. Yeah. And then go ahead and connect. And then by looking at the graph, we're able to identify what our x-intercepts are. They are 0, 0. And 4, 0. Our y-intercept is 0, 0. Axis of symmetry. The axis of symmetry is that very first value of your vertex. And you want to write it as an equation, x equals 2. Domain, since it's a quadratic, it's going to be all real numbers. And then range. As long as you know this value of your vertex and which direction it's opening. This one is opening up. From -4 all the way to positive infinity. That is our range. It will never go any lower than -4, but it will continue to go to positive infinity from there. Yes.
How do you do that?
The very first number of the vertex. The very first number of the vertex tells you your axis of symmetry. Yes.
You're confident you keep going to the original.
Do you keep going from the original
One,
point?
two,
Yeah, from the original point, yes. Okay, let's go look at example 2. Graph the following and find all its unique characteristics. So it gave us this function here. Make sure that it's written in the correct order. You want to start with highest exponent first, then the x value, and then the constant, the number without the x. Which direction is this? Is this one going to open? Down. Good, because the number in front of x squared is negative. So this is going to open down. This one is called standard form. It's not as easy to identify our vertex from this one, but it is very easy to identify your, does anybody remember? Y-intercept. Awesome. What is your y-intercept? It's 8. The number without the x is going to be our y-intercept. So 0, 8. Okay, now for axis of symmetry, they have given you the formula for that there. To me, that looks a little bit confusing. To find axis of symmetry, we're going to start with negative b over 2 times a. And that will give us the x value of our vertex. So this value here, 2, that's our b value. So let's do negative 2 over 2 times a. A in this case is negative 1. And then simplify. That is the x value of our vertex. So put a 1 here. In order to find the y value, we're going to plug 1 into our function everywhere we see an x. And then start simplifying. 1 squared is 1. 2 times 1 is 2. For a final answer of 9, 1. When we plugged in 1, we got 9 as a result. That is our vertex, 1, 9. So that's where we're going to begin. So from the origin, go right 1, up 9, put a dot. All right, from the vertex, I'm going to go right 1 and square it. 1 squared is 1, so let's go up 1. We could also use that same rule going from the vertex to the left. If I go left 1 and square it, that would give us 1. So go down 1. Now going back to the vertex, let's go right 2 and square it. That's 4. So let's go down 4. 1, 2, 3, 4. And then mirror that across the y-axis. From the vertex, let's now go right 3, square it to get 9. So let's move down 9. 1, 2, 8, 9. Mirror that across the y-axis, and that's enough right there. Looks like our x-intercepts are negative 2, 0, and 4, 0. Maximum or minimum. Oh, thank you for pointing that out. So this opens down, correct? It opens down. So it kind of is opposite than what you think it would be. If it opens down, then we have a maximum. If it opens up, then we have a minimum. Another way of looking at it is this graph will never go any higher than that point there. That is its maximum. And your maximum is always the y value of your vertex. So we have a max at 9. Axis of symmetry, x equals 1. That's the first value of our vertex. Domain, all real numbers. Range, this graph is pointing down, so negative infinity, comma, and then it will never go any higher than 9. That is our range. Your assignment is on Delta Math. If you need